Let me recap some more for some time because it's almost 3 4 days, I guess. Okay. So let me recap that. So what is Kubernetes? What is the need? So we are just discussing about around, I think so, 10 points, I believe, because this is a very core kind of a, I can say it's kind of a core architecture or core kind of a components from the Kubernetes side. Like, first of all, why need Kubernetes? Then as a customer, why I can choose? Then we have discussed something about features about GKE. Then we are just talking about workloads and mode of operation, and architecture also we have been discussed. Then of course application of Kubernetes. Anyhow, end of the day we have to deploy application only. Then couple of use cases are also we are discussed. Then end of the session we are done, like security, storage and networking here. So let me go one by one more time, the short span of time. So basically the main core components is the use of GK is like Google Kubernetes for easily cluster creation. We can maintain the load balancer automatically, auto scaling, auto upgrades if we have any kind of a versions in terms of application level, in terms of infrastructure level. Infrastructure level means, let's say I'm using Linux operating system or I'm using Windows operating system for my application. So let's say they have might be upgradations, right? Maybe some minor upgradations and major upgradation. So these all things we can do by auto upgrades. We don't need to log in for every quarter in a year. Generally what happening, every quarter in a year. So every vendor like Microsoft or like Windows is a Microsoft, Linux is Red Hat, right? So they might have a patches basically, because this is a normal process for every vendor, not only for Microsoft, not only for Red Hat. Red Hat means belongs to Linux operating system. So we have a different vendors for different operating systems. So we might have a operating system level patches, right? So in the cloud computing, when we were in the on-prem, everything we have to take care of it, because since we are using on-prem infrastructure, so every quarter in a year means we have 4 quarters, right? Every 3 months means every 3 months we are calling as a quarter. Every quarter, vendor will release the patches. Patches is nothing but a bugs, guys. Bugs in the sense, let's say there is some bugs which is happening in existing operating system. So from the vendor perspective, they have to fix the bugs, right? Because everything is not 100% perfect. So any bug will raise any time. It depends on how application is behavior with the operating system or operating system itself. They might
Today,
be have a same.
on the first day, we clean our homes and discard all old useless things.
Guys,
First day ఏం
Sam's.
చేస్తారు? Clean our homes.
Yeah, just try to unmute yourself. Okay, please make sure. Yeah. So where I was, huh? So when we have a, basically patches, basically, so that kind of a patches also it will do upgrading without manual intervention, because everything will take care of by Google itself. Because since infrastructure is taken care by Google, especially cluster concept of Kubernetes here. And auto repair also, yeah, anything it's there, parts will recreate. Anyhow, that part we can done at the realm of lab itself. And logging and monitoring is just common part, because whenever we are deploying application, even though we are using the monitoring logging in app engine and Google functions, right? When we are using serverless computing also, we have seen the logging and monitoring as well. Once we deploy the application, we do enable the monitoring, and we have checked all logs and what exactly happened, some XYZ we have seen in the monitoring. So logging and monitoring is the common, but the main core is easy cluster creation and load balancing and auto scaling and auto upgrades and auto repair. These are the main important for AKS functionality. Once it's done, yeah. So this is the main GKE cluster architecture about here. So we discussed it in the last class, like first user here using nothing but an application. So user is using the applications from here. So by using of kubectl commands, we can make cluster creation. So here we have a components like pods, networking, load balancer, operations, storage, scheduler, resource controllers, right? So resource controllers means where we can control all the resources, which are the core components from the AKE basically. Of course, here also AKS is using API server. API is nothing but an application program interface. It could be any server. Like if application is using Apache, if application is Tomcat, if application is using any kind of application server, we are calling as app servers, then they can use towards API server only here also. And pods, your pods basically it's a container. I mean containers in the sense a set of unit where we can do container based applications in order to provisioning of any software using the that means my application will be sitting under the pods only. But it could be one pod, it could be more than one pod. So depends on how your application about to deploy in your cluster. Means it's architectural decisions taken care by cloud architecture. So based on them you have to take count. Let's say they requested 8 pods. When you are creating cluster we have to give 8 number like that. So based on the architectural decisions we have to take pod count and node count as well. So when you are creating cluster we can do like that. And coming to VPC networking, virtual private cloud basically. So where we can create networking. Here also we have a networking because without network we cannot make the connection establishment in terms of communication. Of course passenger disk is needed. Without hard disk we cannot store anything, right? So in our case if I want to what I say installing operating system like in Linux or Windows, I need some disk storage space, right? So here also they are maintaining some disks only. Load balancer, very well on cloud operations, whatever we are deploying our applications, my applications will give the service to the customer. So this is the technical level, just kind of a it's kind of a workflow mechanism. So how application will check in the code by using of YAML. It could be container images. We have a different scenarios, right? So in our deploying of my application, so like the way, so how we can just kind of a some technical architecture about how application will do deployment using GKS. Yeah, I just about to showing here. Anyhow we'll do lab definitely. So this part, yeah, this part, what is this? Yeah, this is the CI/CD only. I don't want to go because you know very well about that. So this is the cloud extension. This is what is this? We submit. Yeah, this is the networking because how Kubernetes cluster will making the networking basically. Here also, it's the same thing, same subnet, same IP addresses, same private IP addresses. Here they are using the VPN connectivity. Let's say this scenario will happen. Let's say in your case, I have an on-prem application, but I about to deploy into my this GKE cluster, Google Kubernetes cluster engine. I need to suppose to my on-prem application. I'm supposed to be deployed into my cloud space here. Yeah, still towards VPN internet connect, we can do that. For this, we have to create the virtual primary network. But in our free subscription, we cannot able to create the VPN because VPN is completely pay service basically. So if you want to do on-prem to cloud communication, VPN is the must required in order to deploy your on-prem application into Google Cloud, Google Kubernetes engine basically. So let's go. Those are the main components and services. So let's go to your GCP console here. If you want to create any kind of a cluster using Kubernetes engine. So where is your Kubernetes engine service? If you see, go to your compute because Kubernetes engine also one of the serverless, one of the compute module, right? So just click on that. So if you see here you basically lot of things you can see here. One is the cluster, one is the workloads, another is the services and ingress, and fourth one is the application, and fifth one is the secret and storage. Update both is nothing much important. Migrate to another nothing much. Backup is important and config management important. Of course, everything is important, but regularly what the main core components is the most important, I would say here. So once you have ready with these all things, whatever we have discussed in the theoretical part, then you can make into one cluster here. The first part is if you go through the cluster here, if you click on create cluster, you might see two things here. One is the standard, which is the basic plan because we are using free subscription, and there is the autopilot is the expensive pay per pod. Okay, this is the paper node, but still we have a quota already in the free subscription. We have a quota for node, but paper pod means it's completely enterprise. Enterprise license means we have to pay money. So let it be go with GKA standard first. First, let's see what are the components are there. Here, everything you know very well, but how GKE is manages all resources like networking, security, pools, clusters, machines, then you just need to understand that's it. Otherwise, there's no new thing here. Everything, let's say one by one. If you see here, this is my cluster, basic level information I would like to give. Here, just I can give my cluster name here. You know very well what is general, what is regional. Let's say if I'm creating my cluster, first the architectural need is, sorry, yeah, the first architectural need is, let me take one example that would be the really best. Sorry, yeah. So let me take my architectural diagram for one of the requirement. If you see in this diagram, how GK about to provisioning for one of the scenario. Let's say here there is one application. Okay, this application, it could be any application. Okay, so by using of Dockers, I need to push my application image, which is a container based application. I need to push into my container registry. I will explain what is Docker as well today, because for GKE you have to know about the Dockers as well, Dockers and containers. I will explain soon now. So by using of Dockers, I can push my application, which is a container based application. I can push into container registry. What is container registry? If you see here, we have done a lot of things. If you go your CI/CD, this is the container registry. Whenever your application is deployed, automatically by using of containers, it's stored into container registry. In the last classes, we have done a lot of application deployments, right? If you see here, image gallery, GCF, imaging, these are the applications in the last classes. So we have made a lot. So during that time, we use the containers basically. Whenever a container based application is deployed, of course, different scenarios, it's stored into under container registry, because container registry itself is a repository, but don't confuse like version control system repository and container registry. Repository general term means we can store some kind of a anything, any data, right? But resource version control system repository means that is also storing or maintaining some data in the context of version control system. Okay, don't confuse. Both are we are calling as a repositories, but the context is here we are saving the images of our application. But in the G repository, which is it could be Google repository, it could be Git repositories, we are maintaining code in the context of version control system. Means we are maintaining some metadata, or we are maintaining some data where we are differentiated by the versioning size. Of course, we have the dedicated commands and everything. We played a lot of commands like git commands and grepo commands, right? So like that. But this container registry, it can save, or it can, sorry, not save, it can store our application images, simply we can say. So these are all the application images. So for that purpose, where is my diagram? Yeah. So similarly, today also the application of this application should be container based image. Then by using of Docker here, I can push into container registry. From here, I need to create the cluster here, because once I push my application into container registry, first I can create Kubernetes engine. The requirement is 1, 2, 3, 4 nodes. Means the requirement is 4 nodes basically, means 4 clusters. So first of all, I would like to create Kubernetes engine. Then I can go ahead with the 4 nodes. Then end of the thing. After all configuration done, once my cluster is ready, then my application will deploy into my load balancer, nothing but my target, because end of the day any application has to be deployed into the endpoint itself, any HTTP API, right? So like that way we have to create based on this diagram. Simply nothing is different here. We are taking similarly as usual, taking one application, pushing. This is the new thing Docker is using here for new thing. I will explain you soon. But container registry, you know very well, in the last applications also we have deployed as a container based applications basically. From here there are new things. Earlier it was like app engine and cloud functions, everything. But here we have a new engine like a Kubernetes engine as a part of serverless computing. From there we have to create 4 clusters. Then I have to deploy my cloud load balancing as well. So coming to here, go to again my Kubernetes engine. So first create it, go to standard. First try to understanding what are the options are there. So this is the cluster name. You can give any name. My first GKE means Google Kubernetes engine cluster. So you can give any cluster name here. Then Coming to journal and region. If you select journal, it will come US Central 1C, because what is the zone? A set of a data centers in a region. If you select regional, if you see US Central one, so we have a different regional. Now I think so 28 or 27 we have a Google, regional kind of a things. So if you select regional, it will show you here. It will select journal. You can create it. So most probably, please try to go with, sorry, journal means this thing, because in a region we have a set of data centers. For US Central, we have 1, 2, 3, 4 data centers we have in the same one region. If you go with, let's say, West, US West, 1, 2, 3, we have 3 data centers. So likewise, according to your requirement, according to your client, based on client suggestion, we have to take journal, because journal will decide by customer only, because we are not taking any decision. We can give the options only, but decision will taken care by customer only for the journal, because they know about their businesses, right? So let's say if my customer is belongs from UK, then they will take it as a nearby data centers like US and UK and everything. If my customer belongs to, let's say, Australia, then they will take by nearby data centers basically, because which is very near to their country. But if my application is a global level, all right, if my application is a global in the sense, doesn't matter what country or what region it is there, all users across the 200 crores users, 200 crores only, right? Yeah, I think so, 200 crores something. So our global how much people population is around, I'm not sure, 200 or something like that. If all are using my application in a global level, then I can choose best data centers. Best in the sense, US is one of the best, and Europe is one of the best data center, and or else Australia also one of the best data center. So we have reputed data centers where they have sophisticated kind of a proper data center, big data centers, I can say. Now recently they are about to establish in the Hyderabad also, right? So like that. So we about to choose best data center across the global, I mean worldwide. So during that purpose, you can journal or regional, you can select anything, because if you select regional, automatically whatever zones are there inside the US center, it will take all necessary. If you select journal, then automatically whatever we have, then take the all necessary data centers. So it's kind of a vice versa. So take any kind of a journal, then go to control plane version. Means if you see the here static version and release version, let's say it's all about Kubernetes version basically. So if I take static version, then we have a multiple versions. We have multiple GKE version. If you see here, we have a lot of 1.22 point GKE, 1.27, one more. We have older versions, we have a newer versions also. If you choose static version, then you have to choose manually, because what happened, sometimes your application need specific GKE version. Because let me explain the most important, an interview also they will ask you which version you are, which GKE version you are using, which Google Kubernetes Engine version you are using, like that. So let me explain here. So let's say I have an application, like I have a Oracle application. Okay, just an example. I have a Oracle, some like HRM application. So this HRM application will be compatibility with my 1.22.01 version of GKE. Okay, because maybe they haven't migrated from the application perspective, they haven't migrated a higher version, which is compatibility to advanced version of GKE. So for the time being, because application will not stop, right? For the time being, what they needed, still they upgraded of the latest version. So please maintain our GKS version, whatever this application is compatible, which is 1.2201, like that. During that time, your cluster has to be create static version, right? Static version, just select whatever your application is compatible. So they will tell you what GKE version will compatible to their application version. So accordingly, you have to take the version from number from them. Then simply you can come and select any version. Let's say in my case, let's say where if my application is compatibility with 1.19.16, yes, we have to take the statically. Otherwise, if you take release channel, if you take this, it will take latest version. Means the GKE which is maintained by Google. So it will simply take it whatever the latest version. If you click on this is the latest version 122.6, 121.9. So why 122.6 means it's still in the beta version basically. Most probably it's a beta version. That's why they have segregated like default one. So once this version would be deployed into production from Google, then it will be released and published into our customers basically. So as of now, it's 1.2, 1.9. So it's taken like default, but for us, we can take any application, right? So it doesn't matter what is the version. So whatever I'm taking as example, that will be compatible for my latest version. So, but when you're working in the live projects, please make sure you have to check your application developers which version in terms of compatibility my GKE has to be used. Okay, sometimes what happened, we can start by higher version, simply we can try to deploy this version which is not compatible. Definitely the cluster will not create, cluster will create but deployment will not happen. So please make sure it, and please go through just at least minimum 2-3 versions, because in the interview context, so they might ask what is the version of your GKE. So once it is done, then you have to come to node tools basically, right? So see, all names are same, repeating here whatever we discussed in the theoretical in the last class and today's also, right? So that's why I am going to explain each and everything. Okay, if you see here, this is the node pools information. So the new cluster will be created with the latest one of the node pool, of course. Yeah, so what is node? If my application is going to sit on the pods, nodes are the main important, because without node we cannot run any kind of application, simply I can say. Because that kind of architecture has made by Google by using of Kubernetes here basically. So this node pool contains, of course, name is common, number of nodes. Number of nodes is nothing but how many my pods. If you see here, this is the node 1, 2, 3, 4. I have 4 nodes basically, nothing but 4 clusters. Means one point, sorry, I forget. Server architecture basically. I mean, manage servers and everything. Sorry, I forgot to ask you before the explanation. మీకు node servers idea ఉందా అండి క్లస్టర్ లో? If anybody don't know, please tell me as of now. Otherwise, మీకు అర్థం అవ్వడానికి ప్రాబ్లం అవుతుంది మళ్ళీ. Otherwise, I can explain you.
No, sir. No, sir. We don't have idea about it.
Sorry, guys.
Please explain.
I thought in my mind ki everybody knows server. Okay, fine. So before coming to here, I need to go back some bit background. Sorry for that, for my overlooking. Okay, coming to server. What is server basically? Server is nothing kind of a operating system where we can deploy into any kind of a virtual machines, right? So server also one kind of a software basically. It could be any server, like Windows operating kind of a server, Linux operating kind of a server. So we have a lot of server in the market where we can use to maintain the resources basically. So in our case, we are having Kubernetes server here, Kubernetes server. So by using of this server, by engine, Kubernetes engine will take all necessary action in order to create the cluster first. Okay, so first of all, what is cluster? That is the main important here. So the cluster means nothing but a set of servers. A set of servers till why? So why in the sense, in the production basically, in the productions, we cannot use single servers. Why? Because production means live data. So my server capacity should be more efficient in order to handle my application basically for my all requests. So for that purpose, when we are creating cluster, only I said, right, PP and prod, we are going to create the cluster. Rest of the environments, we cannot create any kind of a cluster. For only production, we are going to create the cluster. Why? Because for lower level environment, lower level in the sense dev environment, integration environment, and user accepting test environment, maximum we cannot create any kind of a cluster. We can use only single server. We can use only single server. But Why? This is not live data. This is not a live environment. Live in the sense, this is not a production. Means here we can use kind of a only limited kind of a users where we are calling as a pilot projects. Means let's say I have a 1 million users in my business. I cannot test all with 1 million users in my lower environments like UAT environment and development environment, because these are the live users. What I can do, I can take simply 1,000 users or 2,000 users, make it as a pilot project. Then these two dummy users will use lower environments in order to test your application first, application or infrastructure, whatever we have. Once everything is good, then I can create one kind of a production replica that is calling as a pre-production. Means pre-production nothing but a replica of production. So here I can use minimum load like 1 million mean 10 lakhs. I can take minimum 5 lakhs users. 1 million means 10 lakhs if I am correct. Yeah, 10 lakhs only. So in the pre-production, which is the replica of production, still I can use dummy users with 5 lakh users. Then I can check my infrastructure, I can check my application again. Once everything is ready, then only I have to go production, because this is the process. We cannot directly build production directly. We have a lot of process behind the scenes. First, I have to create development, then integration, then UAT, which is the user acceptance test environment, then pre-production. If everything is perfect, then only I can create the production where I can deploy my live application here. So till lower environments, we cannot create any kind of a clusters, but till pre-production will come to the picture. Why? I'm almost testing the load of 5 lakhs users, means half of the load which is the live data. Half of the load we are putting into pre-production means if I take single server, it cannot handle, because one server, if my application is running, if I have only one server is one machine, one virtual machine. Then if one virtual machine is down, what happened? Nothing is there. There is no backup, right? So that is why cluster is come to the picture. Cluster means I can create 4 virtual machines. 4 virtual machines. If one is not responding, I can route the traffic to second virtual machine. If my second virtual machine is not responding, I can go 3 and 4. We have a options wise, right? Because at least I have a backup. Because sometimes servers will not respond properly. During that time, we need a backup of that. So for that purpose, cluster is needed definitely, especially for production kind of setups, basically as a part of the infrastructure here, because without cluster, we cannot create live application in the production environment here. So here, these servers will deploy earlier only one virtual machine. Like in the starting classes, we have deployed Linux operating system, we have deployed Windows operating systems. But here, the similar kind of a servers, these servers could be anything, guys. We have a application servers, we have a operating system servers, we have a software kind of a server, we have a lot of servers. Based on your application, we need to deploy into my virtual machine. And after that, you have to deploy only in the virtual machine only. So in the production cluster, we have minimum kind of a setups. In our context, we are calling as a 4 nodes, basically 4 nodes in the sense 4 virtual machine we are going to provisioning here. So if your customer said 10 also, yeah, you can go ahead with 10. If your customer say 200, I don't think 200 will take it up. In the free option, I think so it will take 1110 only, okay, not beyond that. The max of nodes is 1110 only. For pay as you go, you can use as per your how much you are paying. Then you can take any number of nodes here. So that count of virtual machine you have to set up in the cluster. So this all set of virtual machines we are calling as a cluster. So these virtual machines we are installing by our servers. These servers it could be anything: operating system, application software, and what I can say, anything, any software. It could be application software, it could be server, it could be any kind of a installing of your configurations as well. So cluster is nothing but a set of servers where we can deploy into particular deployments and particular data center. That's kind of setup we are calling as a cluster, basically. So here If you come back here, then give pool name here and here, because GKE లో కొన్ని టెక్నికల్ టర్మ్స్ మాత్రమే డిఫరెంట్ గా ఉంటాయి. డజంట్ మీన్ దట్ ఇట్స్ ఎ న్యూ. If here they are calling as a node pool nothing but one server basically. Okay, normally we are calling as a server, but here they have given name like a pool basically. So here I am giving 3. You can give anything. If you see here, pod address limits the maximum size of the cluster. So I am enabling auto scaling. Enable auto scaling means, what is auto scaling? Based on my load, my server scale has to be auto. So 0 to 3 is the minimum. I can give 6. 6 means, let's say as of now my traffic is 1 million. Suddenly it's went spike. So till it has to be 2, auto scale has to be happen till 6 nodes. Means additional 3 virtual machines automatically deployed with the same kind of a structure. Same kind of means, I need to explain it. So I have a 3 servers already, means 3 virtual machines or 3 pods, whatever you can call. So this is my application. So this application deployed here, deployed here, deployed here, working fine in my production. So suddenly spike is happened. Already a couple of times I told you what is the spike means. I have 1 million transactions using by this application. Sudden spike is happened by 2 million users are using. What happened? Based on auto scaling option in the GKE, it has to be at 3 more with same configuration. Means, let's say A, B, C. In the A, I have a .NET application. I have a Windows operating system. I have some XYZ, anything. So in the cluster means, cluster main, the rule is these 3 should be same in terms of operating system, in terms of version of operating system, in terms of application software. Each and everything should be same. I mean, it's kind of a Xerox, I can say. Yeah, Xerox is the correct word, I can say. Whatever A or VM is having the configuration, similar kind of a configurations B should be have. It not be have, it would be like that only, I can say. The same C also, it would be like that. So when auto scale is happening based on your load, D, E, F also would be deployed. How the A is looking like, B is looking like, C is looking like. Same Xerox. Let's say I have main document, then I can take 6 Xerox copy. What happened? Whatever content is available in the main document, the same thing it will be print, right? Wouldn't be changed? No, right? It cannot change. So Xerox will take it as it is kind of a data. So here also, whatever A, B, C is having all kind of a configuration, as it is, D, E, F also will be deployed. Earlier, what happened, if I want to do scaling here, I need to check A, B, C. I need to take all configurations. And similarly, I have to deploy into D, deploy into E, deploy into F, which will take minimum 7 to 8 hours. If I want to do, see, before cloud technology also, we have auto scaling concept, but it will use time taking basically for a lot of human efforts. Let's say I have .NET application, Windows and XYZ. So similar kind of images by using of containers, I need to deploy it here, deploy it here, deploy it here. Just assume that here by any engineer, any DevOps engineer, by mistakenly, let's say .NET, I have a 2.3 version. By mistakenly in E, they have deployed 2.1 version. Just assume that before before cloud computing, what happening? By mistakenly, engineer deployed lower version of .NET in this particular E. So my request will work perfectly, A, B, C, D, F perfectly. When the request route to E, it will not work because my version of application is wrongly deployed, right? So for troubleshooting purpose, just imagine what is the issue, because infrastructure is ready, everything is perfectly good, everything is healthy, everything is perfect. But when you are routing the request to E server, it is not working as expected because by mistake of cloud engineer, they have deployed lower level of .NET project version. So to avoid such a kind of a scenarios, so this is the beauty of auto scaling, means whatever I have .NET 2.3, .NET 2.3, it will Xerox it everywhere and deploy my application simply. So without blindly we can follow. Even though whatever we have written in the images blindly, we can deploy into all pods or all servers, whatever, blindly. Even though you don't need to cross check it as well, because we are telling to system that we have to deploy like this by using of GKE engine here. So that's the one of the beauty of this kind of a cluster by using of GKE here. Means there is no tension. There is no human intervention here. Once you set up ready, once your once your image is ready, same image, it will go A, B, C, D, E. Image is nothing but a one set of template. In this template, you have to write templates using the YAML file templates of app.py files, right? They have mentioned Python version 2.6, like XYZ, XYZ, XYZ in the last practicals. Same kind of a template images by using of containers, it will take it into deploy A, B, C, D, E, F, because the template is common for all servers. It won't change. Earlier, there is no template. You have to go log in and you have to deploy the as it is software. A lot of nonsense was happening in earlier days. So that's the beauty of this auto scaling as well. And what else? Enable auto repair. Auto repair nothing but if pod is having some unhealthy kind of a behavior. So GKE engine means Kubernetes engine will take care of auto repair. Auto repair means if something happened, pod will restart automatically. No need to log in and do restart of pod. No, automatically it will recreate. Earlier, what happened before pod concept? Cloud engineer has to be logging into that particular. So let's say E is not responding properly. So I need to log in into EV virtual machine. Then I have to restart my machines here. But here, everything, let's say this health is not good and this is unhealthy state. So this pod will automatically restart within 2 to 3 seconds. Earlier, if I want to restart any kind of normal our servers, it will take minimum 2 to 3 minutes. But here in the GKE architecture, the pod will restart within hardly 2 to 5 seconds. Max minimum is 2, max is 5. So such a kind of things it will do it here. And next, coming to nodes here. So in the nodes, of course, I need to give my configuration, like what is my image type, what is my machine, right? I need to give a machine means in the last classes we are discussing about E2, N2, lot of things we are discussing, right? So here we have to select generation of your basically your which kind of a virtual machine is supposed to be take it for this creation of cluster. So here you have to select it, but in your practical labs, please take E2 because this is the standard only. If you go N2, N3 means it's very high chargeable. So just try to practice purpose. Please try to take E2 series. So my machine is belongs to E2 series. If you want to go high sophisticated, click on computer. This is the C2 series. C2B is a more high sophisticated again, and GPU is the very very high sophisticated. So just click on general purpose only because we are not at all creating very high level kind of a production cluster here. Right? We are just creating very basic level kind of a cluster here. So machine type E2 medium, 4 GB is fair enough. That is fair enough. And boot disk type standard take. Let's take not 100 GB. 40 is fair enough to me. Otherwise, it's a chargeable. So next, what is the main thing? Yeah, I told you right. The maximum ports is the 110 here. Okay. So maximum port for node means each node. Let's say I have here how many nodes? 1, 2, 3, 4, 5, 6. So I have a 6 nodes. Each node can maintain by minimum maximum is 110 ports. Just imagine, even though if we have huge number of complex business also, GKE will support. Means if I have one node which is having 110 ports, like into 6 means I have a 670 ports. Oh my God. It's very huge kind of server setup basically. 670 applications you can simply deploy into AKS as a single unit. We are calling as a single unit. So simply by using of GKE, we can use more than 600 applications. Just imagine in the single infrastructure, in the single virtual machine. So that's the main beauty of this kind of architecture basically. That is why customers is choosing nowadays is AKS because the of course everything whatever I told many times, the futures XYZ. And network tax, nothing we can network tax. What is tax? Tax are nothing but just indicating that to audience basically. Because I told you at every resource, every service, we have a tagging system. If you want, you can use it. Next, come to security. Of course, what is security? Nothing but allowing the traffic. If I'm allowing the traffic, I need to maintain the like firewall rules and controlling. When we are talking about networking concepts, so we are discussing about what is the inbound rules, what is the ingress rules, everything we had discussion, right? So here by default GKE will create the networking kind of a communication here. We don't need to go and create it. No. So by when you are creating the cluster, automatically IP addresses will take it care of by Kubernetes engine here. Metadata, this is not much important, but still I'm just formally explain that. So add in the metadata, so we are just applying the label. Let's say this cluster is belongs to one project, so just add the project number, like this is Java project and GKE cluster. If you give like that, if anybody sees this particular cluster in the Kubernetes, they will understood that okay, this cluster is belongs to Java project and this is the cluster setup. And tains, what is tain? Even though I don't know what is tain. I think so this is a new option, I believe. Node tains, let me check that. SGO marker so that the scheduler avoids to print using the certain parts. Okay, maybe they have introduced it newly. They are meant. Oh, it's a beta version. Okay, so that is what. Yeah, it's not a live. It's a beta version. So I'm not sure whether because in my production I don't see this option. Maybe this console is the latest version of GKE. So, but that too it's a beta version. Okay, beta version means still Google team is working on it. So we cannot use beta versions in the production. I told you very clear in the many classes, we cannot use beta versions or beta options in the production. Only licensed one only we have to use in the production. So even though I'm not sure about that. Prefer no schedule. I don't know about this. So later, if it's moved into enterprise level license, then I can try to explain. Okay. So yeah, that's related to this. These two options are new actually. Yeah. Once node pool is ready, then just go to cluster kind of a things here. So once we are about to create the cluster, these all things will come to the picture: automation, networking, security, metadata, and features. Most important is network and security only. This automation, metadata, features, this is not at all important, but security networking means okay, which VPC we supposed to be used in this cluster, because in the VPC networking team will give IP address range. Very long back we did the practical one. Let me go one more time. I will show you what is VPC network. That's why starting 10 classes are most important at the time of basics. So if you're talking about here networking means, this is asking the network. Here I have already given VPC. This VPC is created inside the VPC here. So just go your VPC. Where is my VPC storage? Yeah, this is my when we have done the networking labs. This VPC we have created, I think so 4 or 5 VPCs we have been created in the past labs. So once you create VPCs here like this VPC, let me create one VPC anyhow. I will explain that. If someone is missing, just try to understand it here. So VPC means virtual private cloud network. Means nothing but we have to create one network where we can restrict our resources by using of IP address range, region, name, nothing but a subnet here, and we have to give range. Once you given the range now, so last time we have given 10.0.0.0 to 26 like that we have given, right? So like that way we can given the range, then we can create the VPC. So once you created VPC here, then that VPC I can use it here. Already I have the test 1, 2, 3, I believe. So that is what it is showing here. Means whatever we have provided the IP range here in this, yeah, this is the test 1, 2, 3. Whatever I have given the IP range here, this particular cluster will allow only this IP ranging of the your application. That is the controlling. See the beauty of here. Still my application is public, but still I'm controlling. Means I need to save my application from the hackers, right? So this kind of a networking kind of a rules will, or VPS creations of kind of a setup will save our kind of a cluster setups, especially production cluster setup, from the hacking, from the any kind of unwanted traffic, it won't allow you by using of this kind of gateways and IP address ranges specified. So here I need to mention my VPC here. Once I take it here, this cluster only take the traffic from this range for deploying of my application here. Of course, here we have a firewalls rule as well. If any networking team, if they write firewall, because firewall rules will write by networking team basically. So if they have written any kind of a rules, automatically those rules would be applicable to here. So that kind of a setups we can take it from here. And security is just kind of a enabling and disabling property of this. Let's say here I want to enable Google groups for airbag. If you enable this cluster will be accessed by any person who is having the airbag tool. Okay, so enable workload identity. If I have a service account, right, this is my service account, this is my project, this is my service account. So enable workload identity means the person who is having this kind of a service account access. When I was talking about IAM, I was talking about, I explained you what is service account, what kind of roles we have given, right? So that kind of persons, they can easily access to this kind of a cluster, because here I am an admin, I can create anything, without having any access. But when you're working in the organizations, you can't get each and everything like admin role or a super admin role. No, if you're working in the GKE, you have only GKE kind of a role. You can't go like another network kind of a creation. No, because in the live projects we cannot maintain by each and everything by single cloud engineer. No, we have a different departments. We have a storage departments, we have a GKE department, we have a deployments department, CICD. So we have a different segregation. But as a part of a course, as a cloud engineer, we have to learn everything. Okay, so once in the service account, then you can do that. And this is the most important, this property, enable application layer secret encryption. Let's say when you are creating deploying application in the cluster of GKE, I want to encrypt now my secret. Secret is nothing but a username and password, because if I want to access my application without credentials, how I can deploy? So by using of this my application username and password, it could be encryption format. That means it won't take the static values. It won't take like data format value. Let's say encryption means, let's say my username is some app and password is like password 123. Okay, these two are my application credentials. If I'm passing, whenever you are deploying any kind of a cluster, then it won't print app. This app way will convert into encryption. Encryption means it could be right like zigzag number 01ZD $1 symbol 1. I mean zigzag number, right? Random kind of a encryption method will generate. So this encryption will decoded as a YAPA, and password also it will not print in the deployment time. So this password also it will print as a jumbling number, like the random number means 1ZE dollar negotiate symbol @ like that. Because if someone sees, అవి మెమొరీలో గుర్తుపెట్టుకోలేము ఇవన్నీ, because these are security and concerns అన్నమాట. So we cannot directly use our username and passwords directly in the deployment. It should be an encryption model. So that's why it is taking, if you want security wise, yes, you can do enable it. Okay, so like that way. And this is also beta version, even though this option is not available. Enable confidential GKNS, I'm not sure, but this is the still beta model. Okay, so in production we can use beta, but maybe soon they will release this function, this property as. So meta features is nothing, just kind of a functional only. So once you understand this cluster basics, default pool, node security, automation, networking security, this security belongs to networking, this security belongs to pool wise, don't confuse. Okay, so then we can create one cluster. That is what I told you. You have to understand the first cluster setup architecture about the Kubernetes here, because if in the interview if they explain, first you have to know each and everything about whatever we discussed today. Then you can go to now practical, then you can explain it. Majority of the people, what happened, directly they will start like, I will deploy application into parts, khatam kahani. No, you have to explain the architecture first. with each import, with each component, whatever I explained just now. Then take your application as an example, which we are about to do practical soon. Then explain it. Then it will take around 10 to 12 minutes. Out of 30, you can kill time 10 to 12 minutes. It's not an ordinary. It's a very big amount of time. And top of that, it will get some good impression as well, because Kubernetes is the very rare people are there in the market who knows very deep dive. Actually, I can say very less people is having such a kind of a deep experience on it. Otherwise, people just know about just definition type of things basically. So now let's move on to our practicals. But before going to practical, one part I would like to finish it. Let me Dockers. Because in Kubernetes, we have a Docker system, Docker functionality. I need to explain it. If I explain this, then everything is complete. Then we can start the practical. So what is the Docker basically? So let's say I'm keep on telling software application. So let's say I will take on real-time application here. Who knows? You people give an application. Let's say health project. Okay. Health project. Let's say, I think majority of the people, you might have Omega application, I believe, right? So this application is using by customer, right? Sorry, users basically, and maintaining by the customer basically. This Omega application, this is a healthcare application, repeated application. So this Omega healthcare application is using in the GKE, means in the GKE, we are about to deploy this application. Just assume like that. This is my scenario. So this Omega application, I create as an image first. What is the image? I need to put my software and make it into image. So how I can make an image? Docker will come to the picture. First of all, why I should create as an image means earlier days what happened, I will take as application software, then I can go manual, I can do installation and everything for in each each server, because earlier we don't have this kind of a methods and all those stuff, right? So before cloud computing, I need to go on every machine, every virtual machine, then a server need to go, I need to download the Omega software, then I can do installation. But now we don't have that much of time, right? Simply I can make Omega healthcare application as an image. You might hear about the Windows operating system image, you might hear the Linux operating system image, right? Similarly, for application softwares also, we can make it as an images. So if I want to make it images, then image is nothing but such a kind of a file where my application will be having all kind of a configuration in the context of image wise. If you go here, already we have done some applications, right? Let's go to container registry. Where is my, yeah, this is my container registry. So how my application is deployed? By using of this and these images. If you see here, every deployment we have an image. If you see symbol, the same symbol is showing here, right? This symbol, this fish symbol. Docker is basically using fish or ship symbol, ship kind of a fish kind of a symbol. Why I can explain soon. If you click on this, see, so my application software here make it as a simple kind of a image here. This image I can pull it by using of containers. Of course, we have a Docker commands as well, and make it as a manifestable. Of course, this manifestable file will create automatically by Google engine. We cannot create anything here. Automatically it will create. So if you see here, this is my repository, and this is my project, and this is my Docker manifest and image tab, and this is my main. This image will be make it as by using of this thing when your deployment is happening. So that kind of images I need to create from application. Then this image will reusable across your world. Means wherever your application is there, wherever your infrastructure is there, I can simply take image, then I can reuse it anywhere. You don't need to go download the software, installation. No, everything we can do by automate by simply using of this kind of images. But before going to do kind of images, we have a Docker kind of a functionality by using of Docker commands. We have a hardly 2 or 3 commands. I will show you when I'm, when I'm doing the lab. So we have a hardly Docker pull, Docker push command, such a kind of a simply 3 or 4 commands are there. By using of Docker kind of a command, we can make the images. This image will helpful to deploy my application into cluster, this part by using of Kubernetes engine. So this Docker push image into container registry. From container registry, my application will take towards Kubernetes engine, then deploying to my target. My target is nothing but a pods or servers. The normal language is server, but GKE language we're calling as a pods. So that is the main beauty of this Docker. But earlier, what happened, in the before cloud computing, separately Docker engineers are there. Means Docker role is there in the IT projects. We have a Docker engineers are there. Docker and the containers. They are dedicatedly for creating the Docker, this kind of images and everything. But now only cloud engineering will take care of everything, because the process is very simple now. Earlier it was very lengthy. You need to create Docker image file, you need to execute Docker commands, you need to create Docker image, then push into container, then you have to run. Now it's everything simply creating one kind of a deployment, then you are doing everything, because cloud computing is offering like Google, so everything is an automated process. Nothing, no need to do much from your side on anything efforts to avoid such a kind of a manual interventions here. So once your Docker understanding also done, then we can create lab. Lab is a big lab actually. It's mine. Let me check. No, lab I will start by tomorrow only. Tomorrow, tomorrow we have a class at 10 a.m. only. Okay, from tomorrow onwards, we have a 10 a.m. So tomorrow we will start the lab actually. It's a big lab actually. So based on this diagram, we will start the lab. We can create 4 nodes. We can take one application. We can use the Docker commands. Then I can create the image. Then I can push into container registry. From there, you can deploy your application. If you understand the architecture, it's very simple to do lab. If you didn't understand, then again it will be clumsy. But anyhow, first time right, obviously, if you do not understand also, I can tell 1 or 2 times or 3 times only, not at all a problem. But most important, if you did 2 perfect labs now, AKS, you are good in the AKS basically. Okay, so tomorrow at 10 p.m. From tomorrow onwards, I think so Shankar has shifted GCP batch to morning session, I believe. Might be you see in the WhatsApp group. So by tomorrow we have a 10 a.m. daily classes, 10 to 11 or 11:15. So by tomorrow we can have a lab for AKS. Then we can do deployment of an application. We can create cluster first. Then we can create one image by using of Docker. Then we can push into container registry. Then by using of Kubernetes engine, then we can deploy our application. So clear? Any doubts so far here?
Just to have one small understanding to make a takeaway from whatever we have discussed today. So just let me know if my understanding is correct or not. So basically, with respect to pods and nodes, the pod is something like an application which is mentioned in our container registry.
Yeah.
And node is something like a virtual machine where our application can run. We can keep how many as nodes as we can. Is that correct?
Absolutely correct. 100%.
Okay, and Docker is something like an application which is in an image format so that we can deploy in.
No. Docker is not application. Docker is a tool. Tool also not.
Okay, tool which consists of the image of that particular application.
Yeah.
Can I take it in that way?
In order to make the image.
Okay.
By using of Docker, you can make the images by using of Docker commands.
Okay.
Yeah. So this Docker will do functionality in terms of pushing or pulling the images from the container registry.
Okay, you mean to say like and again container registry when you talk about, then the process of pods come into play, correct?
No, container registry only store the images only. That's
okay.
it.
Okay.
Yeah. If you see this, just go back. Just go back 1 second. If you see this container registry, it is just storing the images of all
correct.
applications.
Yes.
Yeah, absolutely. Yeah.
Pod is
correct.
storing the entire application of ours, correct?
Pod is not storing. Pod is having the application availability.
Okay.
Yeah.
Okay.
Perfect. Yeah, super. That's
Okay.
it.
Okay, thanks.
Yeah, if we have this kind of understanding, it's lab is very easy. Don't worry.
Okay.
Yeah. Yeah, it's a bit complex topic. This is only one of the complex topic in the GCP, but of course important topic as well. Of course, any important topic obviously is a bit complex. If any technology you will take it, it's common. No problem. We have still 2 or 3 modules about the Kubernetes. We have to keep on doing it this week. Then only we can wrap up with Kubernetes. Then we can go with other topic. Okay. So that's why I am taking almost 1 week time, because for Kubernetes I can close within 1 or 2 days also, but no, I will take minimum 5 days in a week because it needs it worthy also. Okay, guys, any questions? Please make sure tomorrow we have a 10 a.m. Okay, from tomorrow onwards.
Check 1 minute. Chandra,
Yeah.
you have some issue, right? On cloud build. Is it
Yeah,
resolved?
no.
Check. Can you please tell me like what is the exact issue?
So the problem is running the trigger, add the trigger and run the trigger. So it is not.
అంటే మీకు ఏ మేర వస్తుందో ఒకసారి పేస్ట్ చేయరా చంద్ర గారు? చేశారా?
నేను నాకు చేశాను, గ్రూప్ లో పోస్ట్ చేయండి. సో దట్స్
గ్రూప్ లో చేయండి, then some will definitely respond you. Okay.
Yeah, okay, right, okay.
We have a common group, right? So sorry, we have a group, right, for GCP batch, so just post it there.
Okay, right, thank you.
Okay.
And guys, practice చేస్తున్నారా? Start చేశారా? Because almost we entered into DevOps, that too in the main part. So please try to do practices. Okay, if you have any doubts or anything, just make note down and come up with the questions and the clarifications. Okay, so make sure from tomorrow onwards we have a 10 a.m. our class. Don't be forget. So anyhow, we will remind you over the WhatsApp. Please make sure, please be active in the WhatsApp group. Okay, and thank you. That's it, right, Shankar? Do we have anything?
Yes. And already informed over chat from tomorrow onwards. Classes will start from 10 a.m. onwards.
Yeah. Great, and have a nice day. Tomorrow we'll connect by morning session. Okay, bye.